this forum is to provide sort of an open environment for discussing the program as a whole and presenting results and talking about where we're going and in general just keeping the community abreast of activities. Community continues to grow, and so we're looking for new opportunities to just expand the communication chain. We do have, I guess, we've got 46 people online right now, so unfortunately we won't be able to let everybody talk openly. It'd be just too difficult to coordinate. But the chat room is open, so if you'd like to, you can feel free to introduce yourself through the chat room. I might suggest just a short description of your name, maybe the organization you work with, and maybe your involvement in the community. Here's my information. I'll note now that we will be sending out the slides after the event, so don't feel like you have to copy anything down. We'll provide that for you. Also, some other administrative details. I mentioned that pretty much everybody's phone will be muted except for the presenters. The presenters, as we mentioned, you have the control to mute and unmute yourself. We ask that you just mute yourself when you're not presenting. We will have a Q&A session after Alex Bubeck's presentation, and then we're also trying to have an open discussion at the end. We'll see how that works. In any case, the chat room is a good avenue to communicate to everybody, and we'll try the audio options too as we progress. I need to let everybody know that the meeting will be recorded and it will be publicly available, so keep that in mind with your comments and discussion. And then lastly, of course, the slides will be available after the presentations. So here's a quick overview of the discussions today. We're going to start with an introduction from Shaun Edwards. Shaun is a senior research engineer at Southwest Research Institute. He's also the founder of ROS-Industrial program, and he'll be giving us sort of a quick update and a little background on the program and where we're headed. We're then very pleased to have Alexander Bubeck from Fraunhofer IPA. He's going to be discussing a framework called BRIDE, which Fraunhofer has used extensively for software development. I won't try to go into many details here because Alex will give you the whole rundown, but it's a really exciting framework that we're really interested in hearing more about today. And then after Alex's presentation, we'll have sort of a lightning talks, basically 4-minute presentations from a number of community members. In fact, we have 8 members who will be presenting today. So we're really excited to hear sort of the status of various development activities and also some discussion of needs from end users. And then lastly, we'll have sort of a general discussion and Q&A, and Shaun will lead that up, and that'll be constrained by the time that we have available. So with that, I'm very happy to hand it over to Shaun, who's going to give us a little background information on the ROS-Industrial program.
All right, thanks, Clay. The goal of this meeting is not to give a thorough background on ROS-Industrial. So a lot of the information on the slide is just really summary information. The important thing is to look at that graphic there. It basically shows the tasks that industrial robots do now, and it's very much limited to either 2 or 3. And then that last area is just a big bucket of other tasks. But I think we all believe that if robots are truly these flexible workers, that they should be doing a lot more than 2 or 3 tasks. So the goal of ROS-Industrial is to take that other category and expand it out and allow robots to do many different things. If you guys are interested in getting more information, I put 2 links down there that I think are very helpful. One is the What Can ROS Do, which is a presentation by Jeremy Zoss. It's a video. I think he did a really good job of explaining what ROS can do today. And the 1 year montage is basically a video we put together after 1 year showing a lot of use cases of what ROS can do, and we did that using you guys, the community. You guys sent in your material, and that's how we made that video. Just some quick stats on ROS-Industrial. I think a lot of people are going to be interested in this. We've had 32 total contributors to the ROS-Industrial program. That's pretty good. They come from all around the world. Some are do a lot of development, and others have just submitted bugs and patches and such. We have nearly 100,000 lines of code, and the part that I'm most proud of is 27% of that is comments. That means we're documenting our code pretty well, and that's something I want to see from the community is well-documented code, because I think that makes it a lot easier for people to use. You can see some statistics on the website. If you're familiar, we just switched the website in July, so all those statistics are from July. We have pretty good hits on our YouTube video. We got over 50,000 hits on all of our videos put together, but the vast majority of that comes from our montage video, which shows a lot of cool applications. So I moved through those quickly because I want to keep to our schedule. What I'd like to do now is kind of transition to the next presentation that Alex is going to give, but give you an idea of why we thought it was important. If you look at the pictures up there on the left, you see the current skills required in order to develop in ROS-Industrial, and I'm not going to go through them all, but there are a lot of them. And it basically means you have to be a really good software engineer, like that guy in the lab coat right there, right? A scientist. And what we really want is to limit the number of skills you need over to the right, where you see, a GUI that manages all that complexity for you, and maybe some Python coding if you have to do something really hard. And the idea is there that the guy on the right there who looks like he's just coming out of the woods could be able to program ROS-Industrial, and that's really what we're going towards. SwRI doesn't take us all the way there, but it's a good step. So with that, I'm going to hand it over to Alex.
Thank you, Shaun. So, okay, so the deck is mine. So, I want to give you a short introduction into Bright now. My name is Alexander Bubeck. I'm from Fraunhofer IPA in Germany. I'm a developer and project engineer there in the Industrial Service Robotics group. And we work with ROS and also with robots for quite a long time now. And we really like ROS and do a lot of great things with ROS, but working with others in the community and also with our project partners, we also basically figured that there's some challenges in the ROS community, and we found out these challenges a couple of years ago, and based on these challenges, we basically started work on Bright. And so first, I want to discuss a little bit the reason why we developed Bright. Afterwards, I'm going to introduce some concepts, and then I want to introduce Bright itself. And so if we speak about software quality and reuse in the ROS, basically some topics come up. And one of the main issues if you develop software for also industrial robots and also service robots is that you basically don't reuse software quite a lot. So usually it's easier to write a ROS node yourself than to look into the ROS ecosystem and look if others maybe created such a node. Especially when you look into some driver implementation we have in ROS, there are like multiple of them. We have like, I don't know, 6 or 7 implementations for these small fidget I/O boards and things like that. The other thing is that the code is not necessarily always understandable. So we have a lot of different programming techniques in ROS. You usually have to look into the code itself to understand it. And also best practices and even standards are something we desire, but only few standards exist on messages, but not on components themselves. And ROS did a great job in lowering the learning curves for developing software, but I think we can go even further. Like Shaun said, you still have to do a lot of things. And the release cycles in ROS are quite fast. They are not as fast anymore, but still fast, coming from industrial from this industrial perspective. And we often have distributed development for ROS applications. So these are basically challenges we have to tackle. And we basically back then looked into other domains of software engineering, and what we found, and very quite fast, is model-driven engineering. And since maybe not all of you know the idea about model-driven engineering, I will give a short introduction to that. So basically, the best way to understand model-driven engineering is basically visualizing this pyramid. So basically, in the M0 level, that's right down there, that's where most people live. That's the code and implementation level. So you actually write, you don't have any models. That's why it's M0. And in school and university, you basically learn to model things, to create models of things. So that's what you can do basically in the M1 layer. So you create models of a class or models of, I don't know, physical systems, whatever. And what model-driven engineering now brings in is this M2 level. So in model-driven engineering, you not only have models, but you also have meta models. That means you formalize the model mechanisms. That means you have a formalized way to describe these models, and this brings you a standardization in the creation of these models. That means based on these, if you create the models based on these meta models, you can now start to exchange models, transfer from one model into the other, and things like that. So that's where actually model-driven engineering starts. This M3 level is just a theoretic level. That's basically what you have to create meta models in the toolchain. I won't go into that, but the main message is here that you have to formalize your modeling, and you do that in model-driven engineering. And if we look into these other domains which use model-driven engineering, what they basically get is that they can encapsulate the complexity of systems through these models. They can differentiate different user roles in the development process and for the architectures and software, and also this kind of modeling supports the reuse. And when we now take this model-driven engineering and basically look in how it could look like when we put it in ROS, then we basically have on this M2 level this meta model, and meta models and model-driven engineering are also often called domain-specific languages, so these DSL. So you, in parallel to other possible DSLs, you have a ROS DSL. We have to define that. And once we have that, we can create different models of ROS components or ROS parts of the ROS system. And these models are then generated into ROS components by model-to-text transformation. But also these models can be transferred to or from other model-driven engineering tool chains. For example, SysML is a language, an abstract language for describing systems, and you can have model-to-model transformations into that. And another concept which comes out of the BRICS project for basically supporting reuse of software components, the separation of concerns. I really go fast through this concept. It basically means that you implement in a component different behaviors of this component for example, the computational aspects, the communication aspect, and so on. And all these behaviors represent basically concerns of the developer. And the idea is if you separate these concerns as good as you can in the code, you basically can easier exchange these concerns. And when reusing a component, what you often figure is that you only have to change certain aspects or certain concerns of the component, and if you have them in a separated way, reuse basically is improved. Another concept in software engineering is basically differentiating the user roles in the development process. So if we look into robot application development, we have domain experts, for example, image recognition experts and so on, that are very specific in one domain. Then we have the system integrators that have to put the system together somehow. We have application engineers that are in factories programming robots for specific applications, for example. Then we also have end users, for example, the women in the picture there trying to teach something or talk to the carrobot and make the carrobot do something. And then also in bigger systems, we have system architects that are basically the input for the system integrators. And the black and bold things there are basically user roles we already support in Bright. I will come to that later. And with end users, that's work in progress. And for example, architects have already tool chains for that. So speaking of these concepts, the question is now how we basically integrate that in the tool chain, and the result of this integration is Bright. So I now want to give you a short overview. So Bright is an Eclipse distribution that so basically gives you graphical model editors for different developer rules in a ROS development process. And these model editors are based on a model-driven engineering toolchain in the back. You don't have to see that, but that's what it is. And once you model the different aspects of your ROS development, you can use automatic code generation to actually generate C++ or Python ROS code, or also the boilerplate around that, launch files, or the different ROS mechanisms and so on. The code is generated in a way that we separate the ROS dependent stuff from the ROS independent stuff. That means if you are not really familiar with ROS, the only thing you have to really understand when developing, when coding, is the ROS message principle. So what this ROS message description means. You don't have to ever create a topic again or subscriber, publisher, things like that. So you don't have to do that anymore. And because it's an Eclipse distribution, it also integrates with other tools that are already in Eclipse, like CDT for C++ development or PyDev for Python development. And to go back to the pyramid, what we actually created in Bright are these on the M2 level are different domain-specific languages. One for ROS, for the core ROS system, also for the ROS message description, and for Smash, which is a state machine or a state machine library that's available in ROS. And based on these meta models in the M2 level, we created the different model editors in the M1 level for different parts of the development process in ROS. So one thing is the capability editor. Here you basically create specific components. Here's the domain expert usually lists a component of a image recognition algorithm, a component for a certain driver. And you have an editor to create such a ROS capability model. The system integrator has an editor to compose these capability models together into a system model. And after that, if you have a working system or a number of working subsystems, our application engineer can use the coordinator editor to basically create a state machine of an actual application with its configuration. And all these models then are transferred into actually runnable code. That's M0 level. So we have a model to text transformation into ROS components. So we have the actually components. The system model is transferred into launch files and also YAML files for configuration of such a system. And the coordinator model is transferred into a Smash Python state machine. And also the application-specific configuration is basically transferred into a YAML file. In practice, it looks like that. So you have basically a graphical view of a component, a graphical view of the system components that communicate with each other, and different state machines. And the green things down here are the separated concerns that are auto-generated based on the model. Only the computational parts, this orange thing, is actually code you have to write. I just put some example screenshots. I have a link to a video later on. So on the upper left, you see the capability editing, so where you actually create a component. On the right, the system editing. And on the lower left side, you have the state machines that are basically then executed an application. Besides this graphical modeling, we also started work on textual workflows. That means we have a X-text-based ESL. That means basically it's a definition of language based on the meta model that you see on the right. So you basically have a really simple way to configure a model. And based on this text files or the graphical files, you can then also compile the C code out of this model standalone with just from the terminal, so you don't have to use Eclipse. And
better than
hello?
that.
Okay. We also integrate that into the ROS build system. Catkin is currently work in progress. And also another tool is a graphical configuration tool. That means an application engineer has a graphical tool to configure different poses, different aspects of his application. For example, we have a touch-up tool for basically configuring movement targets just using the robot like you are used to when using an industrial robot. Something we work on, that's something we are, which is still work in progress, is roundtripping. That means to generate code out of, generate models out of existing code. That means you take a component and you get the model out of that. For Python, we have a prototype working. So what you basically have to do, you have to generate the AST, that's quite easy in Python. Based on this AST, we can pass that for ROS-lib calls and generate the actually model out of that. For C++, we started using CLang, which is a library. It's quite, it's more complicated in C++, so that's not really working yet. So we are working on that. Also, we look into having the editors also web-based, so you don't have to have the overhead of installing Eclipse anymore. That's something we work on, and also the automated test generation based on the models is something we work on at IPA. So coming back to the challenges I presented in the beginning, so by using components and adapting them, you can basically enforce reuse in the community. So that's something we wanna, also we have Bright 4 and wanna enforce that people are based on the models reuse software more in the ROS community. Also, the code is much more understandable because the cross-cutting concerns are basically separated now. You basically know what part of the code is for configuration, what part is for communication, and so on. And also, the component models in themselves are a kind of documentation of a structure of a ROS node or also a ROS system. Based on these models, you can also enforce best practice or enforce standards, something like, well, a manipulation driver should look like this. That's much easier to communicate when having a model of that instead of a C++ code or something. And also, we work a lot with students, or also people from industry that are new to ROS, and they have also, even if, ROS is quite easy, but you still have a lot of dependencies on like C++ boost things and so on. So people fight with that, and when using Bright, at least these things are shifted more into the later development life of these users. So I'm not saying that you can live without boost pointers in ROS, but it's especially when you're doing the first steps into in ROS, it's much easier with these editors. And also the fast releases can be handled much easier because we just update the templates of the model to code generation, and then most of these things can be done automatically. We also did that when going from ROS build to Catkin, so we adapted the code templates, and then the new structure was generated automatically most of the time. And also the communication between distributed partners or developers is much easier using these models. So all in all, we have quite good experience with Bright up to now. And so to summarize, Bright helps you to separate concerns, also user roles, and the code can be improved quite a lot by that. Also, the reusability is improved with Bright, and in all, basically these techniques are disseminated with Bright. And the current release is still .2. That's about half a year old. I'm releasing the .3 version probably till the end of the year, so that's coming up. And Bright itself is an open source project. We have a ROS wiki page. There's also the link to the GitHub site of Bright, so you find all the code there. You can also post bug reports there or start communicating with me or my colleagues. And so the current .2 version is just released in Bright, so it's just an apt-get install away. And so that's it. If you're interested in the current developer version, there's also a documentation about that on the GitHub page. But I think, I'm sure I will release the .3 version in the next weeks. So that was my short introduction to Bright. Thanks for listening. And I would be very what would be great if you have questions, and I will try to answer them. So just I think Clay will probably change the mode of the conference now, so you can ask questions by phone. If you have no question and you are not interested in the answers, there's also a link to a video of Bright that shows Bright doing ROS and also Oracle's component creation. But if you have questions, go ahead.
Thank you very much, Alex. That's really exciting work. I'm going to open it up now into our Q&A mode, so I think you'll all hear that when I do.
All attendees are muted and may unmute themselves by pressing *6.
So we have already the first question here. If there's a tutorial for Bright. Yes, there are 3 tutorials on the ROS wiki page of Bright, one for component creation, one for system creation, and one for coordinator creation. And these tutorials will also be updated when I release the new version with the new features of Bright.
Okay, I have a question too, if you can hear me.
Yes.
Yeah, okay. In my experience, if you have this kind of graphical tooling and then generate code, it sometimes means that you're losing functionality because you're not flexible as you are in text coding.
Yes, that's right. So what you lose is flexibility. I wouldn't say you lose features, but you lose the flexibility. So in some way, the ROS components are enforced to be in a way, but that's actually also what we want to, because the flexibility on the one side is a good thing. On the other side, it's a bad thing for example, exchanging components and things like that. But Bright was created in a way to also support components that are not created in Bright. That means you can afterwards model a component that's basically created in the classical way by just coding. And if you model the interfaces in Bright afterwards, you can also use these components in systems. So, for example, we Yeah, so for example, we have components for MoveBase, which is not created by Bright, but we can use the MoveBase component model inside of systems for application development, things like that.
Okay, thank you very much.
There's another question about the difference between these techniques and the commercial available software. So for specifically for robotics, I don't know any model-driven engineering software that's specifically for robotics. The most commonly used in the field of robotics is probably Simulink, which is also kind of a model-driven engineering toolchain. The main difference is actually the openness to other frameworks, to other things. So, for example, you can generate C++ code out of Simulink, but you have to do the component wrapper, the communication wrapper yourself, and that's basically done in Bright. Also, we support creating ORACOS component too. And I think when the tool gets more mature, we will support even more tools. So especially, for example, real-time systems are not supported quite well in ROS yet. So you might want to also have something else. So basically, the most important difference is the openness and the flexibility of Bright. I hope that answers this question. About the ROS-Industrial hydro packages, I don't know. Maybe Shaun can give an answer to that. There will be a hydro version of Bright.0.3. Yeah, if some from Robo Business Summit contacts me, maybe that's possible.
All right, thank you, Alex. In
okay,
an effort to keep things moving.
They're built-in failure and error handling in Bright. I'm not sure what kind of failure handling you mean. In the .2 version, the basically one part the most users experience is that if they have an error in the model itself, that basically the code generation just fails. And are built-in failure handling for that in Bright 0.3. So basically, you will be warned if you have errors in your model or failures in your model. Failures themselves in ROS are probably handled by the ROS implementation themselves. If not, or if you have good ideas about how to handle them, just contact me and we can basically put that into the code templates. So the code templates are basically also have much room for improvement. I mean, there are a lot of experienced developers out there in the ROS community. So if you just give us feedback, these things can be handled better that way and so on. Just give us feedback like that and we will put them into the templates.
All right, thanks, Alex. We're going to have to keep things moving here, but I've got Alex's contact info up on the screen right now.
Yeah, so just write me an email and or if you have problems using Bright, just put a bug report on GitHub and I will take care of that.
All right, thanks again.
Thank you.
So I'm going to hand it over to Shaun, who's going to do introductions for the lightning talks here. Shaun, are you there?
Yep, I'm here. Basically, we're doing lightning talks. These are very quick presentations that people from the community can do. The purpose is to promote contributions that people are making. We really appreciate that, and we want to give people credit for what they do, and also communicate that to everybody else so that everybody knows it's out there. We also want to allow people to talk about their needs. And a lot of times you'll find other people have common needs, or maybe they even have solutions for those needs. So that's one of the things we want to come out of these lightning talks. Each person will have 4 minutes. We'll be very strict on that. At the end, there will be a context line for that presenter, and we encourage everybody to follow up after the meeting because there won't be any time for Q&As after the lightning talks. But please, if you're interested in something that somebody brings up, use their contact information and follow up. Here's the presentation, the presenter's order. We got a good number of people, so we're just going to move through this. The first one is from Yaskawa Motoman, Eric Marcel.
Hi. So Yaskawa Motoman would like to take this opportunity to give the ROS community a preview of our next development. As many of you know, the Moto ROS interface was released to the community earlier this year. The interface supports most of our robots, including 7-axis arms. The interface has been well received and is being used in several projects. However, the interface did not support our popular dual-arm SDA robot. So the inability to control both arms and the torso and coordinate everything together under ROS is a limitation. And today, Yaskawa is pleased to announce that we have engaged with Fraunhofer IPA in Germany for the development of the dual-arm driver for the ROS-Industrial. With this new capability, researcher can apply the existing ROS package like Move It to the SDA robots. Details are not finalized, but the driver is expected to be released somewhere around the first half of 2014. So you can look for the blog postings in the near future with a formal announcement and details. Thanks you to everyone.
All right. Thanks, Eric. All right. Up next is Joe Spanier from Caterpillar. Joe?
Yeah.
You're up.
Can you guys hear me?
Yep, we hear you great.
Okay.
Just fine.
All right. We had 2 need slides that we wanted to put out there. The first one is we're after an easier way to do point creation in Move It. Currently, you can do some simple robot pose creation in the setup assistant, or you're just moving the joints around and getting some kind of rough joint positions, and then you can call them by names. We'd like that to be able to be done in Move It, where you can just grab the arm, move it generally where you want, or maybe click a point on some geometry that you have, and be able to name that point from there. We thought that would be useful, and we were also interested in developing a driver for the Keyence LJV laser scanners. These are 2D laser profile scanners, very, very high sample rates, and we have multiple applications that we feel these could be used in if we had a driver available. Some of the things are on-the-fly decision processing about welds, automated quality checks, and elimination of touch sensing for robotic welding. And kind of an offshoot of that is ROS-controlled robotic welding would be really great, but that might be a little bit bigger than just writing a driver for the sensor. So with that, this is my contact information. I didn't have a very good picture, so I didn't include one, but we would appreciate anybody's time or help with those.
All right. Thanks, Joe. I appreciate you taking the time to put that together and let us know what Caterpillar thinks is important. So moving along, the next presenter is Michel Lambert from Canada's NRC. Michel?
Yes, thanks, Shaun. Good day, everyone. So at NRC, we're among the many things we're doing applied research for aerospace manufacturing, the automation of aerospace manufacturing tasks. And one of the main things that motivated us to use ROS is for doing teleoperation. for aerospace manufacturing. So we're developing a software and a hardware environment to prototype human-robot collaborative manufacturing tasks, primarily using a teleoperation device with haptic force feedback. So we aim at automating mostly contact-related tasks, so basically tasks that require a lot of acquired knowledge and where human expertise is still required to do the task correctly. So a lot of empirical assessment and quality assurance. For these tasks, it's usually very tricky to program a robot to completely automate that task. So we figure by keeping expert in the loop to complement what the robot is doing, it would push the envelope and increase the flexibility and the applicability of robots for manufacturing. So, next slide. So what we're working on is using ROS in the loop to provide the link between a master and a slave system. And we want to develop a flexible reconfigurable cell so that we can prototype these systems. It's a medium to long-term project. Right now we're using elements like the MoveIt API for doing online collision detection and providing haptic feedback to the user. The way we want to make these things available is through low-level modules as part of ROS-Industrial, and then if someone is interested in a higher-level application-specific system, we do through licensing, and finally, we also do projects for complete production robot manufacturing cells, shop floor level, so to speak. So I'm almost done with the time. The needs for this, obviously, the main need that we're looking at is a real-time interface for bridging ROS and the master and slave systems. So taking care of real-time communication, also developing tools for real-time monitoring of what's going on and real-time testing. The main elements for doing that are already there with Oracos and RTAI and Corba to a certain extent, but there's still a need to encapsulate all these things and to bring them to a higher level so that we can worry more about the control algorithm development and have this real-time environment, the porting of the model creation to the real-time environment more smoothly carried out and being able to perform tests and monitoring as we run the thing online. So that's the main need or the main bottleneck in our development that we're encountering right now. What else? So it would enable many things that you could do with ROS. Development of real-time components for taking care of dynamic elements and control. Like ROS right now works mostly at the kinematic level. So if you want to include model-based design, model-based control, well, you need that real-time component. It also allows interaction with industrial manipulators at the millisecond level. So right now we're working with KUKA and Kamau robots, which have such capability. KUKA has ROS-I and Kamau has the open controller interface. So the capability from the robots is there. It'd be nice to be able to interact at that level. You can use high-level tools for control algorithm development. We saw a little bit of it with Bride, Simulink, MapleSync, these kinds of things. And, of course, it brings ROS-Industrial closer to the shop floor as an essential component of a production-level robot manufacturing cell. All right, I'm done with the time. That's me. If you're interested, just drop me a line or send me an email.
All right, Michelle, I thank you for that. I think real-time is a real common need, and there's some tools out there for it, but they could definitely be easier to use, and I hope the community can respond to that because I think it's very important. Moving on, TU Delft Robotics Institute sent us some slide material, but they were unable to attend today, so I'm going to do their slides for them, or I'm going to try to do my best. Huish Vanderhoorn is the developer at TU Delft that we work with very closely, and so I'm presenting these for him. TU Delft is actually a pretty good contributor to ROS-Industrial. They support the FANUC stacks. They develop them and they support them. They also created some tools to help debug communications between the ROS-Industrial drivers and the various robots that we communicate with. And they also help a lot with fixing bugs and issues. In the future, they're going to improve the FANUC driver. They continue to support that, and they've signed up to doing essentially what are ROS enhancement proposals to both standardize repository layouts for ROS-Industrial, so to make every manufacturer or vendor package look the same as far as this directory structure. And also they are going to do one with generic I/O, giving essentially ROS-Industrial access to I/O capabilities of industrial robot controllers. And that's a common need that we've heard from a lot of people. So TU Delft is going to take up that charge. They're also going to continue to support ROS-Industrial and through bug fixes and even helping managing repos on our GitHub repository. Two needs that they see are joint torque or tool force feedback. A lot of people have asked to be able to do force type control with robots, and there are some robots that actually support that. Not all of them, but some of them, and you know, that would actually open up a lot of new applications in the realm of force feedback. In particular, you can talk about maybe like an assembly application or a grinding application where you'd really need that kind of control. Also, they're interested in tool velocity control for visual servoing mostly. So the way we control robots today is by sending them a set of joint waypoints. But that's less helpful when you really care about where's my tool position and how can I incrementally change it. And that's where something like tool velocity control would help. There's Huish's contact information, and feel free to reach out if you have any questions about the FANUC stacks, or if you can help them with any of the needs that they had. So moving on, we're going to let Florian from Fraunhofer IPA present. Florian?
Yes, I'm here. So this is Florian Weissert from Fraunhofer IPA in Stuttgart, Germany, and I'll present a new European-funded project called Factory in a Day, which started earlier this year in October, 2 months ago. So the project team consists of various research institutes and universities from small, medium-sized companies and also industrial partners. So in total, there are over 18 partners involved. There's a budget of around 8 million funded by the European Union. And yeah, for more details or a list of partners, you can visit the homepage on factoryinaday.eu. So we just heard University of Delft, so they are coordinating the project. Yeah, this comic visualizes the idea of the Factory in a Day project very nicely. So the workflow will be that there's a group of robotics or automation experts going to the factory floor, analyzing the workflow and decide which kind of tools or components will be needed. And then they will have the possibility to maybe print some components using 3D printing. Then at the actual day of the Factory in a Day project, the idea is that there will be a truck bringing all the equipment needed, and then there will be unloading, setup, calibration, teaching on the factory floor, and then after this day you have a working automation system. So the applications targeted are for short range and not too hard to automate, but really flexible that every 2 or 4 weeks you can change your manufacturing automation in the floor. So to reach these goals, the Factory in a Day project will contribute to an integrated toolchain for developing, testing, and deploying components and applications. and therefore will use and contribute to ROS-Industrial, and will use automated testing and a model-driven toolchain for that. So the model-driven toolchain consists of components development, tools for supporting the system integration, tools for automatic testing, and also tools for supporting the deployment on a real hardware system. There will be a first prototype available in June 2014, and a final release is targeted to October 2015. And all the results will be open sourced within ROS-Industrial, and they will be BSD licensed and available for everybody to use. So that's my contact information. If you're interested, then please contact me.
All right, Florian. Thank you very much. I'm looking forward to those contributions. As some of you may know, we work very closely with Fraunhofer IPA, and they're setting up a ROS-Industrial consortium in Europe, you know, that's to facilitate contributions like this. So we're looking forward to it. Next up is Brian ONeill from Los Alamos.
This is Brian ONeill at Los Alamos National Laboratory. I wasn't really able to contribute slides, but I did want to share kind of what we're working on and a need that we certainly have. The really boils down to adaptive uncertain component assembly. So we want to do assembly where the parts are not fixed ahead of time in their position. So either a visual or haptic part localization and pose estimation, and then also during the actual assembly being able to adapt to parts that are perhaps manufactured not quite perfectly. So it's really motivated by wanting to one part that has a peg on it and another part that has a tube that peg has to mate with, but the tube is not always assembled perfectly straight. It's nominally perpendicular to a work surface, but is not always exactly correct. So versus traditional automated assembly, there's quite a bit more uncertainty where we don't know exactly where the parts are. So a lot of these things that have come up here with force-based component assembly would be something we're interested in. But if anyone is interested in collaborating on some of that stuff, I'd certainly be interested in hearing from you about component localization and adaptive assembly.
All right, thanks, Brian. Brian actually worked here at Southwest Research for summer, and he has one of a very early commit to ROS-Industrial, and we appreciate that he's kind of taken this to his new employer at Los Alamos. And I do agree with Brian. ROS-Industrial has a lot of applications in kind of this automated assembly area. Next up is Simon Jansen from Alton Mechatronics. Simon?
Yes, hello.
Yep.
Thank you, Shaun. We have a small contribution that we're planning on. In this case, a GUI, a graphical interface for industry. Our experience is mostly with industrial partners, so we're not developing as much, but really working together with industrial partners to create demonstrators. And from these partners, we get a lot of feedback about what they're missing and what they find difficult about working with ROS and ROS-Industrial. And one great need that they had was, okay, we were used to graphical interfaces, and if we have to start a robot and we have to set parameters in a text way, that's very difficult for us. So that's what we're working on right now. You can see here an example of what we have in mind. Operators should be able to easily select the robot model they are using, select the number of launch files they want to use, have some graphical debugging tools, those kind of things. This is still in development, and we're thinking about releasing it in the beginning of 2014, and probably as a separate RQT plugin, so that can be used as a extra to all the other existing plugins. For longer term, We're looking at assembly tasks, very interesting from the last speaker, and mainly focusing on imitation learning. So we really want to create something that a human operator is able to demonstrate certain tasks to a robot. And for example, using a vision system, a robot is able to view the demonstration and to extract its own task from that. It's really important for us to think about lean setup time and to be flexible enough and to be able to work with small objects. So what do we need? What have we heard? A lot of things already were mentioned. I'm very glad about it. So dual arm robot. We're very happy that Eric from Motoman already mentioned this. We're very happy that it's possible now because we really want to use that. And again, also the I/O interfacing with peripheral devices like grippers and conveyors, which was not currently implemented in the LOS message, the simple message. So, but also very happy to hear that people are working on that. And in general, if there's some way to get a qualitative measure on code quality, rather than a qualitative measure, that means that we can really go to industry with a sort of a hard guarantee that something will work and why it will work. That's something that we really heard that people really want to have that. So that's us already. We're very fast. This is our small team of 3 people that we're working on at the moment. So contact us if you have any questions or if we can help anywhere. Thank you.
Thank you, Simon. I'll throw out there that we're going to have a blog post on the work that Simon and his group have done. So I encourage everybody to go to the blog and look there for more information. And I'm glad that some of your needs were met by the contributions of others. That's what I really hope for. Next up is Kelsey Hawkins from Georgia Tech. Kelsey?
Thanks, Shaun. All right, so what I'm contributing are a set of drivers for the universal robot that wraps the C API as opposed to the current Ethernet interface that exists. So at the repository at ROS-Industrial, the universal robot, there already is an implementation. It uses a driver. It uses Python. What this does is it wraps the C API. It exposes a faster control loop, which allows you to control the robot at 125 hertz, and it sort of opens up a lot more of the lower level functionality that you really can't get right now. So in the lower level interface, there's actually several different ways you can control the joints. There's a velocity control component. There's you could specify position, velocity, acceleration. There's also a torque control, which I'm sure a lot of people will need for different force control applications. And so, if you wanted to write a controller that integrates sensors like force torque sensors into the loop, or maybe you want just a fast and direct closed loop on the controllers that you're writing for the universal robots, then you really need something like this. And the current drivers are really not a great application for that. So I am happy to announce that the drivers are ready for a preliminary alpha release. I'm not sure if this works on any other robots yet. It works on mine. But I'd like to have other people who have universal robots to install this and maybe try it out and maybe contribute to the existing code base and help us weed out some of the bugs. So all the code for this is actually on a separate branch on the same repo that's up there. So if you go to the link provided, ROS-Industrial Universal Robot, and just switch the branches to the Hydro Development C API, then you can find all the code that you need. There's also some tutorial code I've put up that will allow you to install the drivers on the robot and on the control machine, and guide you through the process of starting up the robot and running a few examples. So here's the system design. I'm not going to go into detail on this one slide because it's a lot to cover, but basically you've got some code that's running on the control box and then that communicates through sockets to a master control box, which has ROS installed, and then you can use the network to communicate with that master box and control it essentially from any ROS networked computer. So the basic design is, okay, again, you've got a control loop running on the control box, and then we use sockets communication with a simple message package that's in Industrial Core to communicate with the ROS Master Controller Manager. So this is off the robot and mediates communication with all the other machines. And so what I just decided that might be useful to implement is the ROS control framework. So what's running on the UR master machine is a controller manager interface, which runs a loop and communicates with the robot. But on top of that, implements a controller manager so that you can write your own controllers and load them dynamically. And so there, basically a quick introduction to ROS control. You have a whole bunch of different controllers like a joint state publisher, a velocity forward controller, a trajectory action controller. And you can't have, some of them you need to stop, you need to start, some of them can't be running at the same time, like you can't have a position velocity acceleration forward controller running next to a velocity trajectory controller. And so you really need to manage these with some sort of, or it would be nice to manage these with some sort of unified interface, and that's what ROS control gives you. So I've written a lot of the interfaces that you would need to write your own plugins that would be then forwarded to the real robot. And then you can write those plugins and load them in, and you don't even have to bring down the robot to test out new controllers. So each of the controllers would be written to communicate through ROS, through servers, topics, services, and that's sort of all up to whoever writes the plugins. And so in order to, since the drivers would be almost useless without a few plugins, I've written a couple that basically allow you to start up the robot and have a trajectory action controller. So there's a trajectory action controller, there's a velocity forward controller, a position velocity acceleration forward controller. So when I say forward, I mean it listens to a ROS message topic, you send it velocity commands, and it just forwards out to the robot the latest message that it got. And and then various communication controllers that publish diagnostic messages and joint state messages. So on top of that, so one of the things that one of the disadvantages to using the C API as opposed to the current interface is that you lose access to a lot of the tablet functionality. So as a part of starting the C API drivers, you have to bring down the controller that is typically running on the robot. And so doing things like calibration can be it can take a little bit of time. And so what I've written is a few RQT plugins so that you can easily bring up the robot and calibrate the joints. And so I have a picture of the interface there on the right, and that allows you to power up the robot and activate the security stops and deactivate them. And so each of the buttons allows you to sort of command a constant velocity to each of the joints. And so that's very similar to the existing interface that allows you to initialize the joints. And so since every time you bring up the robot, you have to calibrate, it's nice having an interface like this that allows you to do that quickly. Okay, so what I need from other people, of course, initial testing and bug finding. I'm actually not sure if the tutorials will, if the system will actually work on another robot, and so that would at least be nice to find out, and help me find the initial bugs so we can actually get it working on other robots. And then once people have those, then writing new controllers would be useful. So I've written a few controllers, but having one of the advantages to using the ROS control framework is that now that the initial wrappers have been written, everyone can contribute and share controllers with this robot. And for interfaces like the velocity interface, since that's a typically general controller interface, just commanding velocities, you can even share it across robots. So you could write a controller for one robot and run it on a totally different one. So the joint action trajectory controller, most of the code for that I didn't write. I just wrote an adapter, which is less than 100 lines of code, and then linked into an existing implementation that Adolfo provided, and was up and running in less than an hour. So having better tutorials for writing controllers, that's something that both ROS Control and the Universal probably need. So explaining sort of the interfaces that are there. A lot of code cleanup is needed, better documentation. The backend controller is not entirely done, and maybe some Python helper functionality. And so I'm Kelsey Hawkins. There's my contact information. If you'd like to speak with me or make comments or help me out, you can contact me here or email.
All right, Kelsey, thank you. I know you put a lot of work into that. I know there's a lot of code in there, and I know that it exposes some really cool functionality. So I'm excited to use it on RUR. I assume others are excited as well. So right now I'm going to go into some very general discussions, but very quick as we're trying to make time here. If you guys remember, probably about a month and a half ago, I sent out a survey, and we got some good results. We didn't get as many responses as we would like, so I've left the survey open. You can still respond in the link below, but some immediate lessons were learned when we did this, and one of those was that people wanted better tutorials and better documentation, and so we've heard that. And we've basically took some ROS-Industrial Consortium training material that the ROS-Industrial Consortium paid to have developed, and we gave training classes for consortium members. And we took that training material and made it publicly available. And we made that we put that out there on the wiki. So if you follow that link, you can go to that training material, or if you go through the ROS wiki using the industrial main page, you can find it as well. Some other things that we've done is we've implemented a code review policy. So the majority of the code that was going into the formally released libraries was always getting reviewed, but now all the code on GitHub, even the stuff that's experimental and not necessarily ready for release, is getting reviewed. So that just adds to the quality of the code, and it certainly allows others to know what's going on and kind of fill in when people in the team change in and out. And as far as ROS release, we kind of lag the ROS release schedule. About 3 or 4 months ago, Hydro was released in ROS, and so either by the end of this month or early in 2014, we will release the ROS-Industrial Hydro release, and you'll look for the email list to learn more about what's going to be in that when new things are there. So as far as this meeting goes, we think it was helpful. We want to hear your feedback, certainly, what you guys thought worked well, what information was very important. We had a lot of people on the line, and we still do, actually. We weren't really expecting that, but we were glad to see the interest, and we hope that the material we presented was valuable for that group. The next meeting is going to be topic focused, so we're going to, as a community, figure out what we want to focus on next, and have a more technically productive meeting for the next community forum. The next so we plan to do these probably quarterly. We hope to do at least one per year at some conference. Hopefully ROSCON, but maybe there's others that people would like to see us have a community meeting at. And we'll let you know when that next community meeting is. Get on the email list, or I'm sure we'll do a blog entry about it as well. All right. So I'm almost done. I wanted to thank everybody. I could put a lot of logos on here, but I don't have permission. So thank you, all of you. I know who you know who you are.
We're going to take questions later.
Yes. So we're going to take questions at the end of this, which we're going to open it up. We're going to open up the Q&A, and anybody can ask any question that they want. So who's going to do that now? Is Clay going to do that? General Q&A?
Yeah, sure, Shaun. We're already in Q&A mode. So there's two options here. One is through the chat window, and one is just by unmuting yourself via the GUI interface. We've already had some questions that have flown through here in the chat window. Maybe we could back up and talk a little bit about those. Dan asked Shaun, what was the survey size? What's the sample size? Do you know how many people responded?
Yeah, so we sent it out to a little over 200 people to the email list and the Twitter feed, I think, or maybe it's 250. Only 25 people responded, so that's not a good statistical measure, but they were all pretty clear that the tutorials needed to be better, so that was valuable. I'd like to point out that almost 60 people wanted to sit on the phone for an hour. I really hope the survey was 10 questions, all multiple choice. So I really hope more people give us their feedback.
There's also a question about the news out of Google this week. I don't know that we at SwRI have anything to add to that discussion, but it's obviously an interesting development for the world of robotics, and we're excited to see what happens, at least from our perspective. Any other questions out there, either via chat or if you want to chime in? All right, maybe being none, then we'll wrap it up. If you'd like to find out more information, you can always go to ROS-Industrial.org. We also have a Twitter account which you can follow if you'd like, which is at ROS-Industrial. And as I mentioned early on, we'll be providing a link both to the recorded video of the presentations today and then also a link to the slides. So you should be able to get the contact info for everybody if you'd like to reach out directly. With that, I'd like to thank you all for your participation today. I'm really pleased with the results and the engagement. And if anybody has any feedback, either positive or negative, about the format that we used today, we're all ears. So please get in touch with us. Thanks again, and that wraps it up.